Confusion matrix. Confusion matrix. Confusion matrix. Matrix. The confusion matrix.
Right, we're rolling.
Okay. Right. Well, welcome back, Alex. How are you?
Hello. Yeah, I'm well. Yourself?
Yes, very good. Still enjoying spring in the UK, which is bright, if not warm.
Yes, the sun is very pleasant.
Last time we talked a little bit about building out knowledge bases using large language models and some of the things we'd use that for, how we have been using it in a few sort of smaller use cases. And today I thought we would dig a little bit more into some of the aspects, a bit more technical in some places, but just to show that it's just not as easy as open up the box and it's all there. What's the sort of front end of this like, in the some of the things that we've built recently, what some of the things you have to think about and the technologies to use in terms of, the starting point of, well, I have a file, or I'm thinking of having a file, having a chat, and then how do I think about getting that into some form of storage or database?
Well, I guess it depends on what your starting point is. The end game here is to have text, funnily enough, but that can come from any number of places. So we spent a long time sort of recording various conversations that we were having about things data science, and we wanted those in the knowledge base, and as recordings they're not much use, so those have all been transcribed. For that I used OpenAI Whisper, which is just a transcription tool. It's probably the most accurate I've found. It's quite slow on my M1 Mac, but it does the job in minutes rather than hours. And so that goes into the knowledge base as text, and so we're using Obsidian, which has a capability to record voice notes directly in it. So you can store the audio and the text in the knowledge base, and then you immediately hit some challenges with data quality, in the sense that Whisper won't pick up everything, especially with my dodgy accent that I say, and it's actually, well, to be fair, it's actually quite good with my sort of soft Cockney, but it's not great differentiating technical terms and certain acronyms and so on. It can't always detect the context and then be able to put the right thing. And that especially goes if we're talking about things like Python libraries, which will have quite weird names, and they're often mistranslated. So there's a certain amount of data cleanse, although I don't go mad with that type of stuff, simply because when you do the second pass, when you're doing RAG or any type of queries, it's actually quite good at picking up that nuance in it can exchange phonetic terms quite well, presumably because it's made the same mistake quite a lot, right? So it knows that these terms that are phonetically similar mean the same thing in certain contexts. So I actually don't bother with much cleansing there, but if you want that text to be presented outside of your knowledge base, you do have to do some data cleaning. You write your notes in plain text and so on, but most of the documents are going to be Word, PowerPoint, Excel, PDF, you name it, and they come with all their own challenges, depending on how the documents were constructed. Obsidian has tools for extracting text from basically everything, but the results are at best middling. Depending on a highly structured PowerPoint, the text isn't really represented in there in any way that makes sense outside of the visuals, if it's a very visual PowerPoint. process I've found is actually just using one of these tools to rip out all the text from the PowerPoint and then getting the language model to tidy it up. Say, well, this is a presentation. It's still roughly in slide order. Can you summarize this up and make it readable? And they actually do a pretty good job of that. Accepting some translation errors and so on. But so from that way, I can get most of the documents or recordings, and that goes for videos as well, into the knowledge base as text and make them completely searchable. So, there's always a few extra steps you have to go through, but a lot of this can be automated.
Yeah. Okay, I'm just going to jump in a bit there because I thought that was very interesting about the different sorts of the different types of document that you can get text from, essentially. And one, there's these, as you say, things like PowerPoint, Excel, loads of different ways, especially in business, that people record text. And they've been around for a while, but it's probably just worth reiterating that ideally, your knowledge base is agnostic of the actual medium that you recorded it on. So when you recall something, you ask a question, you don't necessarily care that it's in a PowerPoint, but you do care that you get some context. Like you say, PowerPoint maybe is probably one of the harder ones because it's not necessarily processing the pictures. And I think there are a couple of new ones in there, which I think some businesses are much better at this. And it's more modern, which is the whole video and audio. And I think, born out of YouTube and influencers and so forth, is this idea of, well, I've got some knowledge, I'll record a video about it, and then, post that up on the internet. And some businesses have been a bit like, yeah, why would we do that? Which is understandable. But I think people are beginning to wake up to the fact that it's actually quite quick to record something like that. You've got something in your head, you can quickly just start talking about it, record a 2-minute video. And then if you can then mine that, as in what we're saying here, turn that into text and make it searchable, that's actually really useful. And I've actually read some case studies of companies using tools like, there's one called Loom, which is basically a sidestep of Zoom. And they start to run their company kind of asynchronous video messaging to each other. So you'll say, rather than send an email to someone, you'll pose 3 questions in a quick video and pop it over, and then they'll reply with the same. A bit odd, but then you get into, I've got some information, I've just discovered some information, been doing a bit of data analysis, I've just found something really useful. What traditionally you would do, maybe pull that into a PowerPoint, arrange a meeting, talk it through with 3 or 4 people. Well, this company now, what you do is you just quickly record, a Loom, maybe even put some graphics in there, load that up. That's done in 5-10 minutes. And then you send it out like an email, and people sort of then come back to you over the next few hours. So they were claiming that it made things much quicker, which I can understand. And then the idea that you can do that quickly, get it down while it's hot on your mind, and then it goes into a knowledge base via the process you're talking about there, text extraction. And then that forms part of your, let's say, your overall project. I mean, this is the sort of, the thing we're talking about. That also sort of led me into the whole idea, we touched on it before, you're now pulling in emails and texts and any sort of Slack messages. Obviously it's going to grow quite quickly. You get a lot of cruft in there, a lot of repetition. And there's definitely a privacy issue there, because now we're recording absolutely everything in order to try and get this knowledge base really, really useful. But it does, there's definitely a line there that says, really, recording everybody's emails, was that really in their contract when they signed up with the company? So there are definitely some odd things there that you kind of need to tread carefully on. And, obviously if you're talking about a team in work and then you're recording emails, well, now we've got an email where you're writing to HR about something, and that's in there. That's, you've got to be really, really careful about this stuff. So I don't think it's anything to be taken lightly, but just to sort of give a flavour of, the totality of what might be there. But so that's good. So I just thought it was quite good, worth lingering on some of the newer aspects and some of the avenues it opens up here, like video and audio. So we'd call that, it's now in a big sort of text database, but now we've got to start liaising with these large language models, your chat GPTs, and this thing that you call RAG. What are some of the sort of steps in now? I know that we've knocked around with chunking and stuff. What's some of your experience to do with that?
It's such a wild west right now. And this stuff is developing really quickly. I mean, vector databases has been around for a long time, but they've only really recently taken off as a part of the average tech stack. And it's sort of really hard to get an encapsulating view on this. So, I mean, it's worth just stepping back and in explaining what we mean by RAG, which is Retrieval Augmented Generation. And really what this is that what the language models are good at is interacting in human language. What they're not so good at is managing knowledge, because they don't have any knowledge at all. They're just probability machines. And so it's great. You can ask it questions about, ornithology or something, and it will get you some answers, and they might be correct. I strongly suggest you cross-reference. There's a lot of information that can be got out of that. But a lot of the time, you have a very specific domain of information, either your business or your PhD thesis or something, and you specifically want questions answered about that, either because you want to restrict that information, or that information is sensitive and you don't want it to be assimilated into the model, or you just want to sort of control what the language model is acting upon. And so this is the sort of the very crux of what a modern knowledge base is. It's your bedrock of information that can be used to sort of limit the domain of what the language model queries. And so what happens is you've got your knowledge base, which is just free text in some sort of semi-structured form, and then that gets indexed locally usually to a vector database. So it gets stored in the same type of vector that the embeddings are in the model itself. And so the embedding is the vector, the mathematical representation of any given document, chunk of text, or even word. And we'll have to come back to word to vec another day, Pete. I think it's worth doing a little history of language models, and our history with language models. But so what vector databases allows you to do is the ultimate fuzzy search. So you translate your query into a vector of the same form that's in your vector database, and it goes and recovers using a similarity score, like cosine similarity, to retrieve all of the documents or bits of documents that have a close similarity to the query. And that query could be, what color is my car? Or it could be, a document, a whole document. Go find me other documents like this. And so that it goes and retrieves those, and then it pulls the text for the bits that it's retrieved, and sends all of that with your query to the language model, with explicit instructions to only use what's in that blob of text sent to it, and then it will return a natural language answer based on the question and what was in your data set that you sent over to it, and it's quite simple in its surface. On the surface is a method that's incredibly easy to implement. It's like 10 lines of Python or something using LangChain or something, but like everything in life, and particularly in language models, the devil's in the detail, and how you store, index, chunk your data matters incredibly to how performant your RAG process is, as does the choice of model that you use, the way that you word your queries, and any number of other things, including the vectorization model that you use, the similarity metric, the configuration of the data itself. The permutations are infinite. And so getting it right and getting it performant, I think is, especially given new models are released all the time, getting that right combination of local embedding model in your index, and remote model with the language model, so that they are sort of paired optimally. I think that never ends. I think once you go down this route, you're always working around that environment.
Yeah. And it's just worth adding that it appears to me that the reason we have to do a lot of these things at the moment is, as always, technical constraints. And one of the main ones being that there's what they call context length constraint. In other words, how much you can feed the model in a prompt. So you can't feed it sort of, 200 documents, because effectively the time it gets to the end, it's being a bit human-like about things, and it either can't cope with the whole length, or if it does, they seem to kind of drop out the middle, or they'll drop out some of the stuff at the end. So you feed it 100 documents asking a question, and it's not looking at all of them, kind of doing a bit of a human thing. And so therefore, there's this whole idea of chunking down and doing a kind of pre-processing step of, okay, well, I'm asking a question, here's the question. First, go and find out, on a, like you say, on a fuzzy search, what's in my database, pick out the 25 documents or chunks of text, or however you've got your data stored, and then feed only that into the large language model rather than feeding all documents. And it's in these kind of pre-processing steps, as you say, where you start to enter this kind of nightmare of different ways of doing it, and you try several different ways. And it's typical data science, really, is that there's no right or wrong answer, but there are definitely optimal and suboptimal answers. And with so many different levers to pull and push, like size of the text that you chunk, do you go to sentence level, do you go to paragraph level? Then you get into, well, how do you define a paragraph? Then you've got edge cases in your documents where that's not quite the case. And so that stuff gets missed. You start to play around with all these little fiddly bits, and then you find it works well for one type of generation and getting text back, and then you find it doesn't work well for another. So there's no kind of, oh, this is right and this is wrong. Here are 27 different levers, and when you start looking at the combinations of those, it gets really quite tricky. And so you're into a sort of test and learn of, well, what's most optimal, what's it optimal for, what's it less optimal for, okay, what are our business use cases, okay, what are the trade-offs that we're willing to make here, and that process can become quite long and tiresome.
But for the RAG process to work, you have to really understand your data, right? I don't mean you have to have analyzed it to the nth degree, blah, blah, blah. I mean that you have to understand the nature of it, and how it's sort of apportioned and chunked up. As much as I believe that the anthropomorphization of whatever that word, you know what I mean, of large language models is the road to hell. It is useful to think about it in the way you just stated it with regards to how a human would do it. So, for example, the context length is like me saying, right, I'm going to tell you all about the stuff that I see around me in my room, and then standing there and telling you about it for 20 minutes, and then saying, right, now you need to tell me what's in my room, right? You're going to get the stuff you heard at the beginning and the stuff you heard at the end, and some bits and pieces from in between. And this sort of same, the same goes for how you sort of organize your data in terms of chunking it up into smaller bits. You might remember the things in this room if I fed it to you a chunk at a time and gave you a little bit of time to think about it. Or it might be that if I pulled all the stuff together that was similar, I've got some books, I've got some guitar equipment, I've got some paintings, and I could, it'd be a lot easier for you to remember what was in there and to tell and to repeat back something about it. And here's where the sort of organization of the data becomes really, really important, because as does the way that you query it, because as you say, you can't send your whole data set there, and asking generic questions like, you ask our knowledge base, well, what do we think about data? Well, if I asked you that now, you wouldn't, despite knowing everything that we know, you wouldn't know where to start with it, right? And then you've also got the problem of your data itself, in that is your knowledge base full of standalone documents of a very specific subject in sort of long soliloquies, or is it sort of little chunks? Have you got a database full of tweets or whatever, right? And the problem you've got there, and as you mentioned, sort of chunking up the data. So what you want is that only the data goes to the model that's relevant to the question you've asked. So if you've got a document that's about 5 different things, and you only want to ask a question about one of them, sending the whole document there to the model isn't going to help, because you're needlessly extending the context length and almost certainly confusing the model, and you're going to get probably slightly garbled response back, and it may even throw its toys. I mean, the Obsidian Copilot will sometimes complain if you're sending it nonsense.
Right.
And so what do you do? That document it's got 5 different topics in it that are distinct enough. You only want to know about topic number 3. Well, ultimately, what happened when you indexed that document is you indexed it on topic, and which is fine if it's part 1 topic A, part 2 topic B, part 3 topic C, which is almost never the case. So the 5 topics are probably mixed around in a bit. There's probably one chapter that is very much the specific topic you want to talk about, but there's other important parts about that all the way through, right? And so, okay, we could cut it at a chapter or part level, or we could try and cut it at paragraph level. But how do you know whether or not you've cut it in the middle of a really important paragraph, and the second paragraph isn't recognized as being similar enough, so isn't sent? And this starts to become really tricky, because and why a certain amount of redundancy in your database is not necessarily a bad thing, because if there is one document with one piece of information that's essential to the story you're trying to tell, and it isn't picked up because of the way you chunked your data set to be sent to the model, then the model doesn't have any knowledge of it. It's not there. It's not going to figure it out. It just doesn't have it. And actually this gets ridiculously nuanced, and it's a problem that is so far from being solved by anyone. I mean, there's leaps and bounds being made all the time, but the chunking problem is a real head scratcher.
So there's definitely some challenges there. But with that all said, you can still pull something out the other side, which starts to go some of the way and can produce some remarkably good results. But again, what we're talking about there, is this the lack of separation between how you put the data in and store it and then how you put it back out, and how one really influences the other. We talked about that last time with, folder structures, and then how you ask the question and then coming back to it and thinking, oh, I know it's in this folder somewhere. It's that sort of influence. And like you say, now we're saying, oh, it's not folders and documents, but chunks. But then, how you chunk it is going to influence the answers that you get. So that's always, like I said, a challenge that's going to persist for some time. Not solved, but some answers more optimal than others. So we do the RAG, as in we provide these large language models with a bunch of documents, along with the question or the instructions. Give me a summary around this, or from that meeting, pick out 3 points. And then it comes back with some sort of answer. Obviously, if you're just straightforward user, it comes to you on the screen. But, there might be some sort of useful thing behind storing that, especially if it's going into a conversation. So you want to restore that answer when someone says, oh, well, that's good, but can you add this to that? So you've got to pass that answer back in as part of your RAG. But is there anything else there after the query goes in? Any other sort of technologies or steps that I particularly miss there?
No, I mean, the thing is, that's the whole process, isn't it? Right. And this is why I always found when the language model sprung up, given that we had some prior experience with the sort of simpler versions of these, I was like, I kept on looking for more, right? There's got to be more to it than this, right? This is like a world-changing technology. And I was just looking at it going, well, it's really basic, right? I know there's a lot going on under the hood, but even then, once you understand how these things work, it's not that complicated. And it's really a brute force technology. And so, no, I mean, it's a bit of a digression, but like the nuance is all in the application for your particular needs. And so, yes, implementing and deploying language models, especially when accuracy and security are folded in, can be incredibly complicated, but it's not technologically difficult. It's not brain-bendingly intellectual. It's simply understanding how these things work. And I think where a lot of businesses are struggling to implement language models as part of their sort of day-to-day operations are finding that the process itself is simple, but supporting and maintaining that process is mind-bending.
Yeah, so let's move on to that sort of final stage. We're getting the results back, and I think we've all seen one demo or another where you have that astounding moment and you go, wow, that's amazing. And then, as we found, now I want to try and get consistent results, and that starts to get tricky. And really for me, this comes down to how you're using it, and who is using it, in terms of, if you're a company, are you using it internally or externally? And kind of, and therefore what control do you have over the interpretation of the results? And it's that interpretation which I think is really interesting, because it's like looking at it as, a test. So you give it 3 or 4 documents, you ask it for a summary, and it comes back. Now, the question is, how do you know that summary is correct? And as we found, when you start to look at this in detail, you suddenly realize that the verb to summarize is not very specific. And we all sort of know a good summary when we see one. We all like to think we're okay at writing our own. But can you really score a good summary against a bad summary? And probably, extremely good and extremely bad are fairly easy to spot, but beyond, well, this one had, 100 words and this one was 1,000, beyond the obvious. Once you get a couple of summaries back, both of about 150 words, which is what you wanted, maybe 3 short paragraphs, something like that. But they feel quite different. Well, how do you grade which one's right? If they're coming from a document with 15 facts in it, they're probably not getting all the facts out. They probably don't need all the facts. But, well, one got fact 1, 2, and 3, and the other one got 3, 4, and 5. Well, is one better than the other? Can you rate one as a 9 and another one as an 8? I mean, and it starts to, then you get into the language side of things, using one word as a group noun over another. And then you start to get into a little bit of personal preference. Well, I don't like that one so much. Or this term used with these words makes me think that you're saying that that's a lot, but really it wasn't a lot. It was a, minority, and these things which don't tend to matter that much, well, they might matter depending on who your audience is. If it's internal, like I say, people in your company, it might take it with a pinch of salt. But if it goes straight out to a customer and they misinterpret, and they may well be within their rights and say, well, look, it said these 3 things, that to me means this, and they're probably right, but it does mean that. And they're not being paid to go, well, it might be right, it might be wrong. So that idea of what's right and what's wrong now really, the rubber really hits the road. And we've seen some big examples in the press. Apple putting its Apple Intelligence laid it over its news. I mentioned this before, and they suddenly started summarizing news articles which weren't real and just models hallucinating them, which probably wasn't a particular problem for Apple, a bit like Google, I'm sure. They've got disclaimers at the top. AI may be right, it may be wrong, but they were then putting other people's names at the top saying, BBC News summary, and then saying the summary was, and it was completely made up. And other news outlets started getting onto Apple to say, hold on, this app seems to be happening quite a lot, and Apple pulled that summarization. And this is exactly what I'm talking about. If that goes internally to BBC, they'll probably go, I can see that's not real, I'll ignore it. But when it goes directly to a customer with the BBC's name on it, they go, hold on, we didn't say that, and that's not true. And so, this idea, the way these models work, where they can hallucinate because they're probability machines, really starts to matter, even down to the point of summarizing things, and how do you test that? How do you have a consistent paragraph of interpretable text that, every time you do an upgrade, make sure that it's coming back in the same way? There's a certain amount you can do to mitigate that, but there is quite a large risk here that it's not going to produce something that you want it to, and you need to make sure that you have some covers around that.
So just on the Apple thing, we know just how bad it can get already, because the whole Signal Gate thing, the Atlantic editor being added to that group was as a result of Apple's AI doing something dodgy. I'm not absolutely clear on the exact thing that went wrong. Go Google it. But yeah, I mean that was like security secrets being like leaked to a a newspaper and stuff. I mean, it was a scandal. Should have been a bigger one. But yeah, that was AI doing that. But we'll stay away from the politics of this for the moment. I mean, there's a few levels here in terms of consistency. One of the things that LLMs are good at is providing output in a particular format, in a particular way, which for me is, a bit of a game changer in terms of, we'll return this in Markdown with this as a table and that and the other, or give it to me in HTML now, and just being really consistent with how you get it to do things. And it's crap in, crap out with knowledge bases. The more you allow sort of anarchy to creep into the way your text data is stored, the harder you're making it for yourself and the machine to be able to make sense of it. So the sort of first stage here is just right. So in my Obsidian knowledge base, I have a set of prompts. So if I've got if I've got to summarize a transcript, I've just got a single prompt that says do it exactly the same way every time, and add this metadata to it, and add a summary, and add a title, and all of this stuff, and it will just do that out of the box, and it rarely struggles. And if it gets it a bit wrong, there's no big issue here. You're helping yourself, though. You're helping yourself being able to access this data programmatically via different tools because of the metadata and so on. So that type of thing they're really good at, and absolutely you should use them for that. To the what's a good summary thing. I mean, that's either a can of worms or Pandora's box, or a Pandora's box full of worms. I don't know. But most people just have chats with ChatGPT, right? And they're not really that bothered if what they get back is accurate, right? Because most people talk shite, right? And so if you're talking to a machine that's talking bollocks, or you're talking to a human that's talking bollocks, it's all the same to me. I think that the problem really arises in a sort of business and technical context, and it, this was one of the first things we spotted when this started to really take off. Is that how do you ensure consistency? Now, why did we jump directly to that? We did that because we are developers, right? And when you write code, it's vitally important to maintain consistency, which is why we have Git and version control and source control, right? So that you can reduce the volatility in that body of information, and so that whatever's running it can do so without breaking, and that when people make changes, that we can see those changes have been made, track them, and apply a certain level of due diligence so you don't break your website or your app or whatever it is you're working on, right? So we've got many decades of experience dealing with managing the complexity that comes with writing and deploying code, and so when you've got prompts in the mix, so you're sending this off to the language model saying, can you summarize this and put it in this format? It's fine in your knowledge base probably, but if that's part of your workflow for your customer service application, things get a lot more tricky. And at the moment you start, whenever I look at complicated, highly structured prompts that say, I want you to do this, I want you to make it look like that, I want you to use this language, here's some examples, I want you to present it like this if it's this type of response, or present it like that if that's type of response. All I see is code, right? Like, that's what code was invented for. We've reinvented code, right? And don't get me started on this one. I remember having a really long rant about this one, and I'm definitely going to do this. But like, we've reinvented code, only more shit, right? And what the tendency of people that are developers who hit this problem is to go, well, if only there was a way of structuring this so that the commands I'm giving the machine are very, very explicit, right? And it's like, yeah, we have that. It's called programming, right? And I think developers like us pick up on this because, so how do you analyze this spreadsheets full of data, or this CSV? Well, I'm not going to get a language model to do it. I'm going to get the language model to write the code to do it, right? So we've now got an agent and a proxy in between me and the code that I would have otherwise had to write to analyze that. But what's being done? Well, code is being written, which, if it gets it right, reduce the time I've spent doing it, but is arguably a redundant step, right? But you have to prompt these machines in certain ways if you want certain types of information. If you're doing certain things, the prompt really has to be natural language English. But if the difference between summarize or create a summary is getting you different results on the same model and dramatically different results across different versions of the same model or different models entirely between GPT and Claude, say, you're in a world of pain, especially if you don't have knowledge of how to manage versions of stuff, right? Because you may think that create a summary or summarize are interchangeable, synonymous, but you find that they're not, and therefore you have to control for that, right? And this is just the input, right? Because what you're talking about is saying, look, we know for a fact that if we always use the word create a summary of, we always use exactly the same prompt to get to summarize this piece of text versus that piece of text, which has all come from transcripts from you and me talking. You know that it's going to do it subtly different every time. It will get the main structural similarities correct most of the time. Everything else is a bit of a lottery, right? And then there's this idea, then how do you programmatically tell whether or not it's produced a good result or not? And that is very, very, very hard because it's all in the nuance, especially where natural language is involved. It could interpret something that was said in that in entirely the opposite meaning, and you would only know is if you read it. Well, of course, by the time you've read it, why the hell did you need a summary? You know what I mean? Like, by the time you spent all this time getting it transcribed, making sure that the output was correct, you know, tidying it up, fixing it, you're like, well, how much time did this really save me, right? So the point here is not don't use language models. The point is be careful how you wield them because it matters a lot.
Yeah, and you touched on a couple of things there, which I actually think is goes some of the way to help these models, which is you can get them to interact with code and therefore APIs. You know, people set up APIs into their code, and so you can start to mitigate the interaction with a model with its lack of real understanding and knowledge by basically training it to go off and use APIs. A simple example is just around counting. They're not very good at counting because they're language models, and if you give them a bunch of things to count, they're a bit variable because they don't know how to count. They're counting, you know, and it's probability in there. But if you see in the instruction, you know, any sort of calculation, any numbers, someone's adding this and this, don't do it yourself. Go off and call this API, which is called add, and give it the two numbers and then present the answer back. And they're pretty good at doing that. And, you know, and that can quickly open out into, if you think about, you know, a company knowledge base, and you could think of, let's say, a bunch of, you know, product technical specifications, you can start to go, okay, well, that's great. You know, we know that people are going to ask for a description, and we've got these very tightly controlled descriptions or summaries or parts lists. And then you can feed that into the model to say, look, here's an API. Here's how the API works. If somebody asks for the parts of product X, then go off and do an API call called get parts and then present that list back. So that's where you start to, you know, interestingly augment your sort of knowledge base with actual real knowledge. And it's also where we start to step into the idea of assistants or agents, because now you've actually got your model actually going off and, you know, not just answering a question for you, it's actually executing some code somewhere and giving you the answer. But for me, that's also, you know, where again it starts to open out, and you can see this kind of exciting world where, you know, if we can get it doing that right quite a lot of the time, then when we know we need knowledge, we've got a way to get that knowledge out consistently via APIs. And then we've got this lovely language model which sees that there's 27 products, thinks this guy doesn't want a list of 27 products, so I'll highlight a couple and tell him there's more to come if he wants it. And sometimes that's just the answer you want. You know, you think, great, I mean, that was really good it did that. So I think there's a lot of promise here, but again, you're into another step into, just because you fed it the the API. It doesn't mean it's going to get those API calls right. So now it's getting the API calls wrong, and now it's giving you some weird message because the API has failed. Of course, as an end user, again, you're going, what? So I asked you about, what products is, and you've given me some number and weird message as a reply. So again, you're into another set of levers, another set of things that can go wrong. But when they go right, I can really see how, this starts to really, really add up and really offers a lot of promise.
Yeah, well, it really does. But as you point out, it's knowing when it's gone wrong is the challenge, and I don't think we're anywhere near solving that. I think I find myself getting spun around in circles when we talk about stuff like this, because I see so many benefits, but then I can I could get stuck on certain things where I really, really wish I hadn't tried using language model for it, because it turns out being a time sink. Like I was using Warp Terminal the other day to do some what was it doing? I was just trying to install some stuff for me, operating system level stuff, and one charged really well, really quickly, quite a complicated reconfiguration job that it just went off and did. And then I'd try to do something else similar, and it just got caught in a loop. And it kept on changing the same file back and forth, having the same issue, getting the same error, and going over and over again. Oh, looks like I did this thing wrong. I better fix it. Oh, looks like I did this thing wrong. I better fix it. It did that like 20 times before I noticed it was just doing the same thing over and over again, which is all a little bit classic science fiction comedy. That's the world that we're in. You know what I mean? And so I think language models being pushed at people for things that they're not particularly good at, and therefore get overlooked for things that they are, right? And it may seem like they're easy to use, but it's like everything else, right? If someone gives you Excel that you've never used Excel before and tells you what it's used for, you're not going to suddenly be doing, accounting. You're gonna be looking at it going, well, I can put a shopping list in it. You know what I mean? And it will do that quite badly, and you'll go, well, this is rubbish. I can't even do a shopping list, right? So that's quite what it's like. There's lots of people out there that can use Excel really well who are not in the least bit numerate or technical or an accountant, and it's really powerful. But did it work like that out of the box? No, it took them a while to figure it all out. Does a language model help someone who's just starting that journey? I find that very unlikely, right? So, it's a mixed bag.
Yeah, no, definitely. So, mixed bag, some good, some bad. Well, it was pretty enlightening. I'm happy if we call it a day there.
I've got so much more to say, but we should not. And reprise this the wonderful world of AI another day. And talk about something totally bloody different. I think we should set ourselves a goal sometime in the next decade to have a conversation that doesn't have any AI in it. But I've got a queue of other things I want to talk about that are either not AI related or only loosely relate to it. So let's come back with some surprises next week.
Sounds good. Excellent. Well, good stuff, and have a good one, and we'll speak soon.
Yep. See ya.
The confusion matrix. Confusion.